So we have with us Eric Vezzoli. He's dialing in from France, staying up late on his Friday night to be with us today. So we owe him a thank you. Eric wears a lot of hats in a lot of amazing places in the haptics space. So what you had for your reading was that Haptics, XR Haptics Implementation and Design Guidelines. And so he was co-author of this with the Haptics Industry Forum. So the Haptics Industry Forum, I'm sure he'll tell us a little more about, but is really leading the charge in the space of haptics in the world. He also studied under Vincent Hayward, who is the guru, and we call him sort of the grandfather of all things haptics. All roads seem to lead back to Vincent Hayward when you're talking haptics space. But we brought him here as an industry speaker for his work with the organization Interhaptics, which I think you also saw to explore that on your homework. And he's going to talk to you about the work that's being done in that industry space. And he also hosts a Haptics podcast that's on Thursdays. I do advise everyone to check this out because he gets thought leaders and amazing speakers in this. Lucas being one that's going to guest on his podcast before. So I think that's it. So Eric, you can get going.
Thank you.
Thanks, guys. Thanks for the intro, and Lucas, pleased to see you again. It's a pleasure. Yeah, so let me share a present. I wanted this to be interactive. I know that it's hard over Zoom because it's far away. I don't really see you and whatever. But I want to make it as interactive as possible. So first, started a couple of words about me. So I have some years in industry experience in haptics in academics. So I did a PhD in haptics, not really under Vincent, but collaborating with him and other folks. And I really like to talk. Probably you will see that in the next 45 minutes. But in general, I've been involved since a couple of years, of even a bit more into basically an understanding of a problem of the global market of haptics. And with the different activities I'm carrying on right now, I would like to address that problems, and this book is part of the solution to that problem. So I have a background both in research and in industry, with both R&Ds and executive work. So in general, what's one of the, let's say, big problems that the haptics market have? This is independent from XR and will help to guidelines a little bit the activities that I did with this book with the other co-authors, and also the things with the podcast and the things that we are doing, is that haptics lacks documentation, really lacks learned lessons and like written documents or videos or whatever that shares past learned experience. This happens often because the survival rate of haptics companies is, I think, much lower than any other company. So they fail much faster and quite more often. And even haptic expert tends to change field. This brings basically to the situation where companies and students also need to relearn the same lesson over and over again, because there is no available documentation onto past lesson learned fundamentally. And this is a thing that I found particularly problematic. And since like 2 to 3 years, I made an objective for the following 5 years to solve or help to solve this problem in some way, or bring to a meaningful contribution to solve this problem. And as Melissa said, we started the podcast with haptics. With the only reason that we started this podcast is to create valuable resources for who wants to learn about the world of haptics. And similarly, the Haptic Industry Forum, which is this industrial association about haptics company, was specifically born for publishing standards and best practices for the industry to solve this documentation lacking problem. And lately, I've been collaborating with Smart Haptics Conference to helping organize this industrial conference, again, with the same objective to spread the knowledge of haptics, not in an academic sense, which is great. There is a fantastic publication, fantastic authors, but more in an industrial implementation way of doing things. Okay, so this is basically the reason by which I'm doing all of this other activity beside my work at the company. But let's get started here. That's a question for you. Is someone that want to raise a hand and define haptics? What's in your own words?
Good question. You can walk to the webcam if you want to be more interactive.
I guess haptics is technology that makes you feel more like you're in a virtual world by like touch and feel stuff.
So yes, that's a good answer. It's an answer that I really like. It's that it's devices or machine with tactile agency, which means that haptics is specifically driven through technology. It's not a tactile and touch perception, where that's more like human perception of touch, right? Haptics is really when I can do something artificially, and there is a device or a machine or a computer which drives the tactile feedback of the specific device. So this is really, there are many different, let's say, way to express this example. This is, I really like it because it gives the impression that the computer and the device it's giving you back some information. And let's spend some words about touch, right? So what I'm showing here on the screen is basically the results of years of research of a company down in California, which is called SynTouch. They developed the sensor that you see on the top right, the green one, which is a customized sensor that is able to capture a lot of data while sliding on material and surfaces. So this is really something that comes from a sensor approach. And just by doing this activity and scanning thousands and thousands of material to allow virtual prototyping of touch sensation, they were able fundamentally to find this 15 dimension of touch, or the 15 different parameters that help them characterize the touch sensation of materials. It is far away to say that humans have these 15 dimensions of touch. Okay, it's just that a data-driven approach on identifying surface material allowed to identify these 15 dimensions. And some of them are described here is macro texture, micro texture, and tactile sensation, damping, and all of these are mechanical parameters. But what's the take? If, however, we superimpose this is for illustration purposes only, but if we superimpose the ability of different haptic technology to render these sensations, what we see straightforward is that they are able to render one really narrow part of the global tactile perception space, even if this one is fake and is probably much smaller than the one that the human that have never been really identified. Even with this one, haptic technology can't really do a large spectrum of tactile experiences. And this is not a problem. This is a characteristic of haptics. So, and the point is that as soon as you start to build with haptics and you think about, okay, I would like to make realistic haptics, usually what happens is that the results are underwhelming. And the reason by which they are underwhelming is that these haptics technologies can't really, by their own nature, they can't reproduce the really large tactile spectrum that human can perceive. So please, if you have any question, raise your hand. I'll be happy to discuss around that. And some of this, and this is really inherent on the fact that touch is a mechanical interaction. So we'll see that in a couple of slides later. If you want to go further in this discussion, in this topic, there is a wonderful paper by Eric Vezzoli, that is a professor in University of South California, that does a really in-depth analysis on how which are the limits of human perception on the different tactile perceptual space, and try to understand how much the technology would need to improve to arrive at the level where you can apply a simulative approach. It's incredible how far away we are from that point today. And let's then talk about human senses, right? And let's think about vision, audio, and smell. Vision, audio, and smell have the common characteristic that all of their receptive field is concentrated in one specific organ. For the vision is eyes, for the smell is the nose, and for the audio is the ears, right? So if I need to build a rendering device for these three senses, I have a small area of the human body that I need to cover. However, touch perception is absolutely not localized. It's all along our bodies, right? And that brings that your tactual perceptual space, sorry, your touch perception area is extremely large. And specifically, it's also areas that moves and interact by themselves. And this brings fundamentally higher challenges on the device ergonomics. So it requires much more effort to create devices for haptics, because you need to adapt with the ergonomics of the human body, which outside from the head have much more variability in different humans. But you also have the problem that the haptics actuator technology that we saw before are usually quite massive. And as shared, they are much bigger than the human perceptual threshold. Let's imagine that you're putting two pins on your finger, right? There is a distance between two pins under which you don't perceive these two pins on one near the other. And this is for the fingertip, it's around 1 or 2 millimeters. To be able to have a retina haptics display, that means that it would be indenting the fingers. And you would not feel that there's two different actuators, which is basically the definition of a retina screen by Apple. You basically would need to put like hundreds of actuators under your fingertip. And these hundreds of actuators will need to have need to be independently driven and need to have specific mechanical properties. And right now, that's basically impossible from a mechanics point of view. We don't have an actuator system that is able to do that. I think the most advanced is Haptics system, and they have 9 actuators under the fingertip. And that's fairly most advanced, and you have the big pumps that are able to drive that kind of technology. Why I'm saying that? Because this has direct reflection on the design guidelines of haptics. And if you talk about, start to talk about extended reality right now. So extended reality is fantastic because from an audio and visual perspective, you can take a lot of inspiration from reality. So you have a 3D visualization, you have all the interaction opportunity that you already learn in reality. You can now use a spatial audio, so you can recreate the same sensation that you have in reality. But the question is, the difference between audio and haptics is that both, visual audio and haptics is that both for audio and visual, we are at the stage where our technology are really not far away from rendering almost perfectly a virtual image of the reality, right? So there is a Varjo which has extremely high definition over the eyelid for the vision. So the technology is progressing really fast. However, for haptics, so we can apply this reality-inspired design strategy. For haptics, however, we are really far away. So the question is, for extended reality, what should we do to create compelling haptics? And this is a routine discussion that I have with implementers for XR, because the first things that they want to do, okay, I want to build a simulation. Let's do how we do in reality. But as we see before, that usually brings to really terrible results. It is something that it's really not satisfactory from a user perspective, and you can easily take like 6 months, 1 year to build a functioning haptic system. So that's basically wasted time. So this is the reason by which haptics is often perceived as hard or not bringing value. And this is a quite common discussion in or feedback from the industry, but the reality is that haptics just shouldn't be implemented with the same design principle as video and content audio. And now we stop here and ask you, does it make sense? You have some comments on this? Or does it surprise you? Does it shock you?
Mike, if you want. Watch the cable sync.
Hi, I was just saying, like, I think it makes sense on a surface level, but is it purely because of the lack of realism and the fact that it's on multiple sensory organs as opposed to concentrated in one? Or do you think there's something else that causes this sort of design principle change?
I think, so great question or great comment. So I think that is mainly driven by the fact that the perceptual, it's mainly driven from this. It's mainly driven from the fact that the perceptual space for each haptic technology is extremely limited. And through that, it means that each haptics technology or device have a certain amount of use cases where it can bring value. But if you expect a simulative approach, it's really incapable of delivering that. So that you need to focus on where haptics make sense from a use case perspective instead of having it from a simulative one. The fact that it's spread over the body, it's an increased challenge, but I believe that that's not the main one. Let's say I think gamers would be extremely happy to have a haptic vest that have an extremely high density of actuators, and even if it's just a vest, that I think would bring a ton of value in that direction. So I think it's really dependent on the technology and the ability to cover the tactile space. But let's move forward here. So this is the reason by which we wrote the book, really. And I wrote it with some folks from the haptic industry. With Chris Ulrich was the CTO of Immersion since many, many years. Immersion is the leading IP company in haptics. I think they have like 4,000 patents, something like this. Heistenbatter is the CPO, Chief Project Officer of SensaGlove, which is one of probably the most accessible haptics exoskeleton for industrial use, beside the work from Lucas. And Rafal is the CTO of Actronica, which is an actuator company that makes HD haptics actuator. So there are folks from the Haptic Industry Forum, and the activity that we did during this book, we interviewed a ton of haptics experts in the both academia and industry, and tried to capture their feedback and try to distill them into an actionable plan, an actionable guide, basically. And the way that we understood that this problem should be tackled is a loop that have a design and implementation loop that starts from the haptics, the goal that you would like to achieve through haptics. You go down to the interactions, effect, framework, hardware, and then you, from a bottom up, you implement it. There is often the activity from, let's say, implementers or hackers' perspectives to meddle with haptics and try to implement it by iterating their discovery with the users. That of course can work, but it's just that it's a lot more time consuming because the haptics pipeline is extremely long. So it takes a lot of time to implement something, test with the user, come back, retest, modifying, retest it. This is inherently on how haptics is implemented into the technology stack. We propose these systems because there is a lot of the choices that can be done on paper and can save a ton of time and money if you are going to implement this in a business perspective, in a business sense. Make sense? Are you following me? You can say yes with the thumbs up. That's fine. Thumbs up. That's good. And I assume that you read some through this activity, through this book. So I'm not going chronologically to chat about that. I'm going to start with probably the most important things that you should take into consideration when you build haptics is that you are building it into a multisensory environment. So you're building haptics in XR while having both a visual and the audio content which are present, right? And the touch is a third sense that you can use to leverage and obtain your objectives, which can be immersive, it can be for a playthrough, it can be for whatever you're going to do. And in multisensory, usually there is these 4 big different categories of let's say, relationship between the different senses. But let's focus in the central one, so primary and secondary. And this is one of the interesting things that happen in XR. Primary, it means that the touch is the most important sense during, let's say, an interaction. And secondary is that is in support of something else, or it's less important than something else. Can you make me an example in reality where touch is the primary sense of an interaction? Does some of you have an idea here? You can speak louder or come near the microphone as you prefer.
Maybe you get shot by a gun.
That's a good one. I mean, you feel it before you feel it before anything else. That's a good one. That's a good one. I mean, if there is a shot, you should have a silencer. But a stupid one is that if you are walking in your room in the night and you want to switch on the light, you use touch to find your button, right? And then you click it. And that's absolutely a primary interaction where touch is the most important one, because you're not seeing and you're not hearing. There's many of them. If you grab a glass, okay, and you drink it, you're not looking at your glass, you're not even hearing at your glass. You're just using touch to manage all of these interactions. What happens in reality is like really an enormous amount of interactions that you do with the real world. Touch is the primary sense. But due to the fact that the haptic technology are really terrible on simulating, in extended reality, touch is always a secondary sense. It's always less important, should always be less important than both visual and audio. And in particular on this multisensory map, when you think about extended reality, haptics should always be used to reinforce the perception that you're going to achieve. So the perceptual objective that your content is delivering should always be secondary, nor it should be, that is easy to understand, it should be on time with the other two. So, or within the latency for not perceiving that it is late, fundamentally. Make sense now? Everything good? Okay, so if you get these global concepts and the latency requirements fundamentally are under 100 milliseconds for slow interaction, like clicking a button, it can be much tighter for fast interaction, like shooting with a gun, that you need like a latency much lower. But in general, it needs to be less than 100 milliseconds. You fundamentally are able to meet the third condition here. And based on this multisensory map here and this latency requirements, fundamentally we can enter into the realm of the haptics interaction framework. What's that? Is that haptics, due to the fact that it's secondary, just makes sense in a context of interactivity. Because it's not the primary, so it makes a sense in the context of interactivity. And in this context, fundamentally have two big haptics interaction frameworks. The left one is called egocentric haptics, which basically you, let's say, think about haptics on the body like a screen, like a display, like that, a monitor, where you drive the actuators as a function of haptic tracks or times. Okay, so it's like seeing that as a loudspeaker, and you play back some haptic effect on a specific part of the body. And this is fundamentally bHaptics, if you are familiar with that. bHaptics is exactly these things, because you have to design the haptics experience that should be played back, and that is played back altogether. based on events and whatnot, but it's played back altogether. Another haptics interaction framework, which is called allocentric haptics, it requires the interactivity in the interaction of the user with the content, and the content sends back the haptics feedback. This is what you have with exoskeletons. It's much, much harder to build exoskeletons and interactivity with exoskeletons and haptics with exoskeletons compared to having an haptic vest, because you absolutely need to use allocentric haptics. So you need to take into consideration the user intention, as well as the feedback of the content with the loop of the delays that we showed before. But allocentric haptics is extremely powerful because you have both time, space, and interaction dependent haptics on a defined map. Whereas with egocentric haptics, when you just do the playback, you have just a time-dependent haptics on a defined map. And basically your expressive capability by using allocentric haptics are much, much higher. So you have much, much more freedom to implement a compelling content for the final user. So to summary up this multisensory part, and we'll start to go into the design part, is that haptics for XR definitely should be a secondary perception, should reinforce the percept, so the objective that your content have, and should have, if possible, zero latency. That's not possible, but should be as good as possible. So the third one is, of course, that's easy to understand. The first and the second should be used to drive your way to design haptics in your content. Okay. But the real question is fantastic. I know that I understood this, but how can I do that? What's the process? And it is what we walk through in the next slides. So we take back the framework that we shared before. So design and implementation loop, right? And so the first question that we pose ourselves is the goals. So what's the reason why we should put haptics in XR content? Okay. And I'm turning the question to you. Can you, 5, 6, 7 reasons why you should put XR haptics in the content? Different than the one that I showed here. Any feedback, any ideas?
Come back to some of our skateboarding ones, like where might that be? I'm also thinking in terms of escape room. There's some pretty clear ones there. Anyone want to share?
I guess, yeah, it just like provides a higher level of interaction with like whatever experience you're doing. You feel like you're in it and you're able to like just do more things than what a controller would allow.
Yeah, that's a really good answer. It is a vehicle of communication haptics. That's true. So it's a way for you to capture information, the content that can talk to you. It is vehicle information and having a better awareness of what's going on. And this is the reason to put haptics inside. So what I put here on the screen are the 4 main reasons that should drive or could drive the implementation of haptics into the content. One is to increase realism. So this is the first one, is the reason by which Haptics company, that you know, if you're aware of the guys that have this big exoskeleton with a lot of pneumatic indentation has been created, is to increase the realism of specific content like simulation. Haptics is used while you need to try if you can mount a new plane, and you can virtualize all of that in virtual reality, but you need to have the ergonomics well done. So even a centimeter off for the hands of the mounter, that's a big problem. So you need to be as close to reality as possible. For that reason, you can use haptics devices, which, however, is extremely different from the immersion. The immersion objective is to increase the sense of immersion of the user, which means that he feels more inside the content. And we saw before, if you apply simulative approach, you actually are delivering to the user a different sensation than the one that he expects. And actually making simulations can actually destroy immersion. So realism and immersion are often orthogonal in implementation of XR content. And you can deliver immersion through delivering specific haptics feedbacks in the specific situation. I give you an example for a skateboard, right? You're running with your skateboard. There is an easy way to make a really good haptics content there is that if your skateboard is going faster or slower, you can change the rate of vibration of your haptics to simulate the texture that this skateboard is getting on the road. Because if you go slower, the road rugosity happens less often. So if you're going at a certain speed, you have a certain number of hit. So your frequency is lower. And if you go faster, it goes higher. This, for example, is used all the time in PlayStation 5 controller when you're driving. So this is not simulation, because you're not taking the rugosity profile and you're doing all this kind of transformation in real time. You're just taking an arbitrary pattern and you're just rendering it faster or slower. But this is directly can increase immersion because you are giving to a user a relatable haptics content with the XR content that he experiences. Then we have user experiences that haptics is really great to increase, to optimize user experience in XR. You say the virtual keyboard. It's great if you have haptics because you feel it straightforward. And there is even an example from Jess Archer from Meta Reality Labs in the book that they actually ran studies there, and definitely haptics increases the user pleasantness of using virtual UIs while clicking buttons. And the fourth one was the major one because of VR training is really it's quite a big market for haptics in VR, is a skill transfer. Is that you actually train muscle memory, or at least you give a bigger feedback to the user, and it's easier for him to train muscle memory with haptics. And in the books, there is many other reasons, but I think these four are the most important one, at least at the level, at the stage where you are. The other are more niche, like for medical simulation or something else. So then we go a level lower, right? We did the goals, and right now we go to the interactions. So next step is sketching out which interaction you need for achieving that haptics goal, and list them. There is even a nice table in the book with the real use cases. I think it's at the page 78 and 79, where basically you have a fully fledged, as we see here, yeah, a fully fledged use case for haptics training, where each interaction is classified with the 14 interaction class we proposed, and then when you go a level lower, you define the effect that you would need in that interaction. Basically, you create your scenario in pieces and then you put it together. Just at that stage, then you should decide your technology, because you have a fully fledged interaction guidelines. You understand where haptics makes sense in this interaction. At that stage, you can decide, okay, cool. Right now I need to choose my device. Often in haptics happens the other way around. So you have a device and you try to fit it into a use case. And that can be destructive because you get carried away on these use cases. So it's much better to think in another way around. And in general, the haptics devices, we classify in 4 different big classes for XR, which are vibration of vibrotactile. So this is the buzzer that you have, controller with a Vive or Oculus. Kinesthetic, which is a force feedback from like a sensor glove or the haptic stuff. You have contact spatial, which is basically or the indentation of a localized sensation under the skin. This is, for example, a Tesla suit. They have this. Basically, they have electrodes under the fingertip. And non-contact spatial, which is quite similar, but it doesn't have a device. This is ultra haptics or the emerge device, basically. Make sense? And when you have that, and this is basically just a taxonomy with the dependency. When you have that, and again in the book there is quite an explanation of which one of these technologies is good for which use cases. You can understand what is the best of your technology for a specific interaction that you want to do, so you can choose the one that brings the most value to your content. And sometimes the answer is, I should not use haptics. I think it's often the answer. Because maybe in my perceptual space that I would need to have a great value for that use case. There's no haptics technology that makes sense. And that's fair, that's a fair answer. And then it happens the reflection part, and you should make wise decision here, because if you start to build the haptics content, it's like having a completely new pipeline, right? There is audio, there's video, there's haptics, but if it's not bringing value to your use cases, you're basically just losing time, and it doesn't make sense. And this is one of the most, let's say, compelling reason not to use haptics that you see here on the screen, is that if you want to have the sensation of the gun in virtual reality, it does not make sense to take the simulated object approach, so taking an exoskeleton and creating the virtual representation of a gun and apply haptics on the virtual exoskeleton. Because it's just much easier, much cheaper to make a 3D printed prop of a gun, stick a tracker on that, and due to the fact that that gun is real, the tactile perceptual space that we saw before, the fact that it's real, it will be much, much, much better than a simulated object. Because a simulation haptics devices are not good to simulate reality. So there's many, many use cases in XR that is much better to put a 3D printed system inside, and that just works really, really well. And you really can't beat that in many, many use cases. Then you have the average one, which is you can get the value of both. You can get a prop, you get an actuator inside, and basically generate a custom haptics device that does a specific thing. Make sense? And again, in the book, we have quite a lot of these tricks, like wearable UI. That's fantastic. I love this. So if you project a UI on your body, you get the realistic haptics while having a projected interface. Okay, because people right now with the hand tracking are just clicking in the air, but if you project it on your body, you have a hard feedback. And that's really great, because it's actually it gives you a kind of sensation like a button, because it has compliance. So that's actually quite satisfactory. So again, there is many of these tricks that if you are an expert, you will get them straight away. If you're not, it will take some exploration, but more often than not, is better less haptics and more haptics, because when it is inside, it should bring value. And if it brings value, it's fantastic. At least the user perceives it as great. And at the last, we arrive at the development tool and ecosystems. So haptics right now is pretty fragmented. There is not a unique tool chain for haptics like there is for video and audio. It's really fragmented. There is a lot of effort to standardize this. We are involved in all of these, most of these efforts. But fundamentally, you can see this like an audio pipeline, but you have a content creation tool chain that deploys haptic assets that are included in game engine. This is not true for everything, because sometimes you have SDKs that do everything and you don't have this haptic asset, so you're vertically integrated. But in ideal world, you should have this haptic asset. And then you have the deployment pipeline that goes through unique APIs, which is not, again, true yet today. Every device has their own API. But this is the development tool chain and ecosystem. So there is many, many different tools that you can use in the function of the use case that you would like to achieve. And some of them are under standardization. Yeah, this one here. So I kind of finished the generic part. Do you have some question at this stage? Otherwise, I will introduce what we do at Interaptics, because at this stage, it makes sense that we share a little bit on that. Yeah.
One of the more challenging things about haptics seems to be going from, okay, I want to interact with this object. I understand intuitively what that mechanically should be, but then trying to drive the waveforms or whatever that creates that tactile sensation, that seems to be magical to me. Do you have any tips on how to interpret that?
Can you please come near and repeat? I didn't really get the question. Thanks.
Yeah. Quick summary being, going from a mechanical sensation, say I want to push a switch, to a waveform driving that particular haptic, seems to me very magical. Do you have any tips for demystifying that and making it a little bit more intuitive?
Yeah. So thanks for the question. It's great. I mentioned that inspiring from reality is bad, but taking cues from reality is great. So what is a switch for a button? A switch for a button is basically a rapid change of mechanical impedance. That's what it is. At least that's what we feel. And it can be extremely well simulated by generating a shock with a vibrotactile system. So there is no magic recipe. However, there is a bit of, let's say, experience there, like any designer that sometimes seems incredible what they do. So you can take inspiration from reality, and also in the literature there are papers or indication which is the part of that realistic signal that actually brings the meaning of what you're doing. In case of a button, is a rapid change of this mechanical impedance, and you can simulate that through a shock. This is one. Sadly, there's no magic recipe there, but there is one thing, for example, we said it before, there is the patterns in reality can be really well mimicked by a pattern of shocks and transient in haptics. So usually what I suggest to do is to take what a realistic signal is and purify it from anything which it feels or seems useless, or minimize it and make it as simple as possible, like as simplified as possible, if you would like approach it with the line. And that is a good starting point. If that thing works, or at least it gives you some nice vibes and it feels kind of good, you have I think a good opportunity then to refine it through design tool and make it great for your experience. If that one straight away simplified doesn't really work, it's easier, instead of trying to improve it, just trash it, because the key part that signal take from reality doesn't bring any value in VR, or it doesn't bring any value through haptics. So we are running an experiment with a consumer, with a business school, trying to simulate realistic texture through vibrotactile devices with the phone on clothes to buy online. And we try to do that by taking the texture patterns from these virtual clothes and try to render it with haptics. What came out from the studies is that this is absolutely counterproductive. It doesn't increase the immersion of the user. People absolutely reject it because they don't get the real feedback. They just get a simulated, a reduced part of that feedback, and that is generating more frustration than the problems it tries to solve. And so the reality is that there is not a magic recipe, and I think that this goes into the direction of we need documentation, we need failed effort and good results documented and shared to the community. Make sense? Did I answer to your question? Great. So what do we do in Haptics? What we really do in Haptics, we built a content creation toolchain for haptics. We have an haptic encoding language. You can see this as how do I write in a digital form a haptic sensation. And we have a series fundamentally of it's a rendering, it's a media presentation engine, it's a rendering system that allows to take these haptic assets and execute them in real time. So basically we are managing the software pipeline of haptics. And one of the first things that we realized is that we really needed a way to design haptics, and we built a specific design tool. This is the one that is right now in beta, that is been designed from scratch with the needs of creating haptic sensation. They have a testing systems, and this haptic design tool is called Haptic Composer. And what is its particularity? Its particularity is that it's based on a codec, which is our Interactive Haptic Codec, which is a way to encode haptic signals, so waveforms as you call them. But sadly, they can be just waveforms because they're haptics device. They don't accept that. They need other kind of signal as an input. Basically, we did a good job. We did a long work or understanding which kind of classes of haptics effect there were in reality in the industry, and we synthesized them in a unique haptics codec. Okay, it is both spatial and temporal. That means it works with both egocentric and allocentric haptics. And last year, there was this kind of standardization process of haptics in MPEG, which are the guys that do MP3, all this kind of stuff. And we have been selected as a major technology at the basis of this future MP3 of haptics, which means that the codec that will help to encode in a smart way or in a fully standardized way an haptic signal that then can be deployed on different devices. But this approach here also helps us to do another thing due to the fact that you have a unique way to encode, or at least a superset of way to encode a haptic signal that encompasses what the industry have. I also have a way to deploy the same haptic content on all the devices. And this is quite cool because we could use the PS5 DualSense controller and the sensor globe with the same haptic asset, the same SDK, and the same content creation toolchain. So basically, yeah, we're doing kind of a unity of haptics, something like that. And to do that, we based on the fact that the research that we showed before is that haptics has a limited perceptual area. Thus, I was able to put them all together, package them, and creating a way to drive all of this kind of technology in a smart way. So basically, this is what we do with Interhaptics, and we basically build and commercialize this software stack that allows to create in a really easy way haptics implemented in XR or mobile phones games or PS5 games, and deploying them on many different devices without changing your code, basically. And I'm kind of finished. 45 minutes presentation. And I will be happy to take any question that you might have. Or comments, or tell me, this is terrible, you're wrong, and I'm happy to discuss from there.
Yeah, so I was just wondering if you can give an overview of like what sort of haptics research has been done using brain stimulation, and if that's at all like a promising area, or if we just know too little about neuroscience and how the brain works for that to be feasible.
Great question. Fantastic question. So that's a great one, because at the difference of vision and audio, I mean, the somatosensory cortex for touch in the brain is external. Actually, the somatosensory cortex is almost exposed. And there are a ton of research going on there. Some of them financed by the military for the prosthetic from the veterans, and some of them mostly for that direction. And there's a ton of research that's going on, mostly in monkeys, because it's difficult to get ethical approval to open the skull of a human, at least if you are not proven. And it has been done a lot of experiments where it was implanted into monkeys electrodes. And in the specific area that has been identified as driving the perception of the, let's say, index finger, which is quite localized here. And by applying a matrix of electrical stimulator in the area that was identified as the one for the fingertip, and sadly for the monkey, cutting out the hand later on, and applying a prosthetic on that hand, and connecting the sensors to the heads directly, and mapping the sensor that you had on the fake fingers to the head, the monkey was able to train himself to use this complete system as a replacement for touch. So that thing actually works. And there are also quite a lot of human experiments ongoing now. So some of them with, I'm not sure if they already opened the skull of a human and put the electrodes inside, but I'm sure that they are doing it at the arm level. So they are putting sensor and interfacing them with the nerve perceptual for the touch at basically the arm at the arm stage, which is actually completely different, because here you have all the pre-processing that goes through the spinal cord that is in haptics exist. You have several levels of pre-processing that goes through every time you have the nerves that have an interface with a new one. You basically get pre-processing there. However, the other way around, you basically have a completely abstract mapping from a sensor to the other. So in both cases, I think it's really promising, frankly. And it's one of the brain-computer interface that I believe it one day will happen, because the brain somatosensor is exposed. The approach of using magnetic field to directly stimulate the somatosensory, however, that's probably a no-go, because it requires extremely high magnetic field that you need basically big magnets to do that, and there is absolutely no defocalization needed to create localized stimuli, because what you want is to recreate localized stimuli, right? So you would like to create something that makes sense. You would like just, if you smash a magnetic field on your brain, actually I tried it on myself. What happens is that basically you mainly feel something, but you also feel your arm just pulls up, because your motor control cortex has also been stimulated. So that's not really great. But electrode implants, I feel it will find an application probably for amputees and people who have prosthetics to regenerate the sense of touch. Probably, hopefully in the future. The problem as a user one, you have infections because you have open brain, so you have problems. All when you open the head, you open the skull, you always have problems. So that's the problem about putting this brain-computer interface here. There is also the opportunity to communicate with the nerve directly.
And has anyone been able to simulate like micro haptic feelings, like, you know, small touches, or maybe different types of like touching water, or these kinds of sensations with brain stimulation?
Yeah, I think that the monkeys with the electrodes implants, they were really, really good at doing that. They were really, really good at creating localized stimulus, because the somatosensory area for the fingertip is actually quite large. And there are almost a one-to-one mapping between a certain area of the fingertip and a certain area of the brain. So that is okay-ish, but specifically for small touches and indentation. Anything which is simulative on sensation like water, that's another realm, because then water is mainly perceived through thermal transition, and the way that the thermal coupling is, that is completely another way, another place actually in the brain. So to go in simulation, I think that's pretty far, but you go to stimulation, that's more achievable from my perspective than let's say visual stimulation, which is completely internal to the brain and goes through different stages internal to the brain, right? That's really hard.
Right, gotcha. Cool.
No problem. Any other questions, feedback, or something that you want to chat about?
Hey, Eric, it's so great to see you again. So I was just wondering, we have a lot of groups that are doing hardware projects that don't necessarily 100% rely on haptics as their main function. So I was wondering, like, if you have anything you might challenge the students as far as like how you could integrate haptics into different devices that don't necessarily completely use them, like locomotion, like VR treadmills, that kind of thing. Like, how can haptics make those experiences better?
Thanks. Great question. Sorry, great question. So it depends if you want to bring custom hardware inside or not. I mean, for the skateboard stuff, do you have actually a real skateboard that people need to jump in or not? Question. If you have that, that's a wonderful opportunity to throw haptics inside. Just put an actuator under it and throw different feedbacks when you are sliding on different terrains, or you're going faster or slower. That would increase immersion like tenfolds compared to just investing into visual content. Because a big part of skateboarding is the feeling that you have in your board, right? And the feeling goes through haptics. So that's one simple way. Another way is that, I don't know if all of you are just using controllers. Okay, that's fine. A haptics controller have a haptics feedback. from my perspective, you couldn't introduce haptics easily in that way by applying the process that we proposed and underlying like events, like hitting something, like underlying a positive. One really good thing with haptics is positive reinforcement. So there is something that the user did well, use haptics to reinforce that. Never use haptics to say that it did something wrong, because otherwise you're also reinforcing that things we said about positive learning as before with haptics. So that's a great way to put it inside. And it's definitely really dependent if you're planning to put passive props inside. That's a really easy way to put haptics in. There's no haptic feedback. There's no active haptic feedback. Passive props, you should use them as much as possible. Just throw a HTC tracker on anything that makes your experience more believable and put it in your scene. Just if it should be a chair or a cube, put chair or cube, put it inside. And that brings an incredible amount of immersion in the user, because suddenly he realizes that it's true and that it's real, and then it acts more believably and his immersion just rises. So to recap, easy way, put passive props inside, as many as possible. They are cheap. They don't cost basically nothing, and they put a lot of value. If you're using a specific tool, like, I don't know if you're using a skateboard, with a skateboard, if you are, take that skateboard and put under it an haptic actuator. Drive it like you can put a subwoofer. That's fine. Put a subwoofer under it, make it vibrate, and use that sound to correlate with the content, like faster, slower, or tricks or whatever with positive reinforcement, and then brings a ton of value to the immersion of the user. These are, I think, I don't know how much time you have to do these things, but this is, I think, the two easy one that you could apply straight away. Beside, of course, controllers about positive reinforcement of good action by the user.
Amazing. Thank you so much.
Thanks, Lucas. Great. For the questions, of course, you can contact me when you want by email or LinkedIn or Twitter or whatever you want. So I'd be happy to. Even if you have your own projects and would like to have some feedback about Haptic, just reach out and I'd be happy to.
Great. We just want to say thank you very much for joining us, Kasumi here. We appreciate so much and you staying up so late on a Friday night to be here with us. And it does through Zoom feel like you are actually here with us and we got to meet you. So we appreciate that experience. Can we join us in giving a round of applause? Say thank you.
Thanks, guys. It's always a pleasure, and thanks for the invite.
All right, thanks, Eric. Bye.
Cheers. Bye. Good luck with your project.